First, as human beings, we look at things in terms of tens because we have 10 fingers and toes. And from the earliest days, as you may remember in school, you may have even counted on your fingers. And that's how human beings tend to think, in terms of tens. It's called decimal. However, computers are different. They can only process in groups of two. And this is one of the things to understand. The reason why it can only think in terms of two is because there are only two possible states of an electrical circuit, which actually makes up a computer. It's either on or off. On is 1. Its current is flowing, like when you put a light switch on, as you see pictured here. And off is when current is not flowing, or 0. So a circuit can either be on or off, 1 or 0. And that's pretty much the only reason that computers think in terms of 2 is because of the state of the electrical circuit. Dimmer switches don't count, by the way, because a dimmer switch, even if there's a little power, it's still on. Now let me just give you an example. In math class, we have what's called the powers of 10. In this case, the number 10 million. To break this down, first you have the ones place. Remember, anything to the 0 power is 1. Well, 10 to the 0 is 1. It's the ones place. Anything that's in here is in the ones category. Then you have the tens place, which is basically just 10 times 1. So anything in here is going to be some multiple of 10. Then 10 to the second power, or hundreds place, 10 times 10, it's going to be in that range. Then you have the thousands place, 10 times 10 times 10, 10 to the third power. Then you have the 10,000s place, the 10 to the fourth power, 10 times 10 times 10 times 10. Then the 100,000s place, 10 to the fifth, 10 times 10 times 10 times 10 times 10. Then you have the millions place, which wouldn't we all like to make $1 million? You have 10 to the sixth power, 10 times 10 times 10 times 10 times 10 times 10. Everything in the millions category, aside from being highly taxed, is going to be in the millions. Then you have the 10 millions place, 10 to the seventh power, 10 times 10 times 10 times 10 times 10 times 10 times 10. The powers of 10. This is how this works. This is basic math. This is how we think. Mrs. Pilecki would be proud. So, if we want to break down the number 412,000, you notice you have 2 in the thousands place, so that's 2,000. You have 1 in the 10,000s place, which is 10,000. And then you have 4 in the 100,000s place. So you can think of this number as 400,000 plus 10,000 plus 2,000 is 412,000, based on powers of 10. With this number, 1,421,331, you have 1 times 1 in the ones place. You have 3 times 10, which is 30, in the tens place. 3 times 100, which is 300, in the hundreds place. 1 in the thousands place, so it's 1,000. 2 in the 10,000s place, which is 20,000. 4 in the 100,000s place, which is 400,000, and 1 in the 1 million's place. So 1 million plus 400,000 plus 20,000 plus 1,000 plus 300 plus 30 plus 1. That's the way the numbers break out in terms of the powers of 10. We think in powers of 10 because everything is multiples of 10. Computers have no clue. And it's not just enough to tell the computer, well, just multiply everything by 5 and then it'll all make sense. Still doesn't work because of the electrical state of the circuit being on or off. It has to be a 1 or a 0, on or off. So let's do an example. So just as we went over the powers of 10, let's now talk about binary, or the powers of 2. Everything is going to be in multiples of 2. So again, remember, 2 to the 0 power, anything to the 0 power is 1. So that's where we start. That's the ones place. Then you have the twos place, 2 to the first power, which is just 2. Then you have the fours place. Notice here, it's multiplying every time you move over. So you have the ones place, the twos place, the fours place, 2 times 2. Then you have the eights place, which is 2 times 2 times 2. 2 to the third power is 8. Then you have the 16s place, 2 times 2 times 2 times 2. Very similar to what we did in the powers of 10, but we're doing it with 2s now. Then you have the 32s place, 2 to the fifth power, 2 times 2 times 2 times 2 times 2. Then you have the 64s place. Again, you're seeing another doubling. 2 times 2 times 2 times 2 times 2 times 2 be the number 64. Then you have the 128th place. 2 to the 7th power, 2 times 2 times 2 times 2 times 2 times 2 times 2, which would be the number 128. Incidentally, this will be important later when we deal with subnetting. So the powers of 2, critically important, because everything you do will be related to the powers of 2. So let's put it all together. Let's actually make sense of how this works. So the number in binary here, 11000000. You look at that and go, okay, wonderful. What does it mean? Remember, 1 is on and 0 is off. So in this case, you have 1 in the 128th place, 1 in the 64th place, and then off everywhere else. So 2 ones and a whole bunch of zeros. There's 1 in the 128th column. So 1 times 128 is 128. Pretty much, if there's a 1 there, you count it. If there's a 0 there, you don't. So we've got 128. Then you have a 64 because there's 1 in the 64th place. Now, what do all these zeros mean? It's all zeros. Now, add the 128 to the 64 and you get the decimal 192. This is how binary works.